Hey everyone, welcome to my channel. My name is Brajesh, and in this video I'm going to show you how to define Kafka producer and Kafka consumer with the help of Spring Boot application. If you're creating a new application, you can just download the skeleton from the start.spring.io. After selecting the project such as Gradle or Maven, language, and then the Java version, we can add the dependency. And for the dependency, we have Kafka. For that, we need to select the Spring for Apache Kafka. With this dependency, if you just see here, we have got the Spring Boot starter, Spring Kafka, and then accordingly we have the test dependencies as well. If you have the existing application, then you can just pick the required dependency and then place it in your build file. I have already defined the application where I have two modules, Kafka consumer and Kafka producer. Let's start with the Kafka producer first, and here we will send the message to the Kafka topic. Similarly, in the consumer, we will read the message from the Kafka topic. For the application, we have the producer application, and here we have used this command line runner. This bean will be executed every time whenever we will start the Spring Boot application. So from here we can call the method to send the message to the Kafka topic. Now for this we want to create one service from where we will send the message, and here we have the producer survey, and we want to send the message to this topic which we have configured in the environment variable. Now to send the message, we have this message where we have the key and the message that we want to send to the Kafka topic. With any Kafka client, we would need to write the code to send the message. But with the Spring Kafka, we need not to write the complete code. We have the already defined template. We can just use that. We will call the method of that template, and then our message will be sent to the Kafka topic. Spring Kafka has defined the Kafka template. So here we have Kafka template. This takes two type parameters. First one is the type of the key. Second one is the type of the value that we want to send to the topic. Let's give it a name template, and here, because this is a service, we just need to auto-wire it. Now we can use this template, and here it has a couple of methods. One of them we can use here. The first method is send, and then it sends the message to a specific topic. Let's use this, and we want to send the message to the topic that we have defined here. Let's copy that and the message that we want to send. And now if we look at our configuration, so here we just have one property, topic name. This is the topic where we want to send the message to. To send the message to the Kafka topic, first of all we need the Kafka server. So I have already defined one Kafka server here. We have the zookeeper and then the Kafka server running. If you need to know how to set up the Kafka, you can watch my another video where I have explained all in detail. And if you have already existing server, then you can use that server. To verify if our message has been delivered to Kafka topic, we have the Offset Explorer UI. Here you can verify all the topic that we have in the Kafka cluster. This is also I have explained in that video, so you can go through how to use Offset Explorer. For now, let's start the application. At this moment, we don't have any topic. From here, we need to call the method that we have just created. So let's send message and key 1 and the value 1. Now we will start the application. So here it has started the application, and let's see if we have got this message in our Kafka topic. So here, if we just refresh, you can see here we have got the message topic, and we just need to see the properties. So here key and value type is a string, and if we just refresh this, so here we have got the value 1. At this time we don't have any key for this message. Here if we just pass key, so this is the method that we are using right now. First parameter is topic name, then the key and the value, and now again we will send the message. Here we have got the message with key and value. At this moment, we did not provide any value such as Kafka server host, port, etc. But still, we are able to connect with the Kafka. The default behavior of the application is it will send to the localhost 9092. Now, it is possible that your Kafka cluster is in different hosts or maybe running in different ports. Then we can define those properties over here, and if we just enable these properties, this is the bootstrap server URL, which is the host and port of the application. If your Kafka server is having the SSL enabled, then you can also provide the trust store location and the password. Similarly, key store location and the password. So these are the configuration that you can do for server. At this moment, we have the local host which is running at 9092, so we need not to bother about that. So I'm just disabling it now. the first message that we have sent is the type of string. But what if we have to send some message which is the Java object, such as the message that we have here? We have the message with ID and message property. Now we will try to send this message to the Kafka topic. For that, again here the message we want to send is the new message. Now we need to send this message to our Kafka topic, and then the value type has to be changed, and here we will change this to message type. And in this send message, now we have got the message, and this is what we need to send to the Kafka topic. So here you can see it is having the compilation error. This is because the message that we are sending to Kafka topic should be of the type of this Kafka template value type. So it is a string. So here we have the message, and now we will be able to send this message to the Kafka topic. Let's see that. Alright, so the application failed, and here we are getting the error serialization exception. While sending this message to the Kafka topic, Spring Kafka container is trying to serialize it, and the serializer it is using is the string serializer, which is a default serializer. Now because we have the message type, the conversion is not happening. That is why we are getting this particular error. To resolve this, we need to have one serializer type. We can define this serializer in our application properties file, and the serializer that we need is the value serializer. So for the key serializer, we are still using the string. So we have the Kafka producer key serializer, and then we have defined the property here. Similarly, for the value, we need JSON serializer. So whenever we define the properties in this property file, for the Kafka related property, we have spring.kafka and then the property names. But if we have properties specific to the producer or the consumer, then we will define them like spring.kafka.producer or spring.kafka.consumer, and then the properties. So here we have the property that we define for the serialization, key serializer, string serializer. This is the default serializer anyway. And then we have the value serializer, which is JSON serializer. Now if I run this application, it will still fail, and here we are getting this no class def found error. And this is because the serializer that we want to use is not available in the class path. And this is the serializer that we have used from some other dependency, which is the Jackson dependency. So let's enable this, and now if we will send this message, we should be able to get this message in Kafka topic now. So let's see that. And here we have the message topic. Refresh this, and now you can see here we have got the JSON, and here we can see the JSON structure as well. So we have the ID and message. With this type, there is one additional information, which is the headers. So here we have got the type ID. So this type ID is the information of the class that we have serialized. So com.bridge.dtos.message is the class, and if you look here with these values, we don't get that information. We are able to verify the messages being received by the Kafka topic. How will our application get to know whether we have successfully sent these messages or not? For that, in the producer, we can also do one more thing. And here in the producer service, whenever we are sending this message, we need to identify the success or failure scenario. If it is failed, then we can reprocess the message, or if it is successful, then we can do some other action, right? Send method returns the listenable future. With this listenable future, we can add the callback, add callback, and we can just return the new listenable callback. It has two methods, one for failure and another one for the success. So here we can just add the message log.info successfully send message. We can define the result. In case of error, we can just define here the error failed to send message, and the message would be this exception. So we have got this message successfully send message. The message has been sent to the topic message topic, and we have the header that is being sent. This is the byte, and here the key, and then the value. This is how you will be able to identify whether your message has been received at the topic or not. Now let's look at our consumer part, where we want to receive the message sent by this Kafka producer. So here we have the consumer application, and we have one service, consumer service. Here we want to read the message from the Kafka topic. With Spring Kafka, we have the abstraction layer again for the consumer part. If we just add one annotation, which is KafkaListener, whenever any message will be received by the Kafka container, then this consumer message will be called. For that, we just need to define a couple of properties. The first one is the topic name. So here you can define multiple topics. At this moment, we want to read it from the message hyphen topic, so you can define it here, or we have the environment variable set, so let's use that. Here we have the topic name. So with this setup, let's run the application. Here we have the consumer application. Okay, the application is failing and it requires a group ID. So whenever we define a consumer, it should be part of certain group so that it does not read the duplicate messages, and also update the offset so that it will not repeat the same message again and again. Group we can define over here in the listener, and here we can define the group, whatever group we want to associate with. Instead of defining over here, we can also pass this in the application property file, and here we can have a group which is for all the consumer in this application. So let's say we have the group ID group 2, and now we have the topic name, we have the group, and if we will run this application, so at this moment we don't have any message, and now if we send any message from the producer application, now let's see what happens here in the consumer part. This consumer is failing, and here we have the failure. In the consumer service, we have defined the message type, and we have got the string message. By default, the deserialization is happening in the string, and then Spring Container is not able to convert this string into the com.bridge message type. So for that, we have to define the serialization properties. So we know our keys is the string type, so we have to deserialize it into the string type. And similarly, we have the value deserialization. Whenever Spring Container fails to convert the message into some type, so Spring Framework Kafka provides the error handling deserializer. Whenever it tries to deserialize it and it fails, then it goes to the error handling deserializer, and then error handling deserializer delegates it to the specific serializer that we want to define. So here we also need to define one delegate, and here deserializer value.delegate.class, and this is the JSON deserializer. Again, this is coming from the JSON library that we have added. Let's try to run this application, and again we will send the message from the producer. Let's see in the consumer side, Java lang illegal argument exception. The class com.bridge.dtos.message is not in the trusted package. We have class com.bridge.dtos.message. This information Kafka container is getting from the headers that is being sent from the producer. So here we need this to be in the trusted package. For that we have the property Spring JSON trusted packages, and here we can define the package that we want to trust. So any message coming with the header com.bridge.dtos should be trusted by our consumer. Send the message from the producer. Again it is failing, and this time there is some other error. Here we have the error com.bridge.dto.message class not found. Kafka container is trying to convert the message to the com.bridge.dto.message type, because this is the header information we have got. Here we have the message which is in the com.bridge package, and we have the message that is coming from the Kafka. That header is com.bridge.dto message. Now if we will move our class to this package, we will be able to handle this. But in your production application, it is possible that the producer is a different application and the consumer is a different application. So it is not possible to have the common packaging, right? For that, we need to see how we can resolve this scenario. This information is coming from the header, and if we just disable the header, then we should be able to handle this. In the consumer properties file, for the JSON use type headers, we are making it false. So now whenever the message will be read, the header information will be discarded. If we run our application by disabling this header, then we also need to define one default type. Why? Because now Spring Kafka container does not know to which type we need to convert this, and for that we have additional property here which is the JSON.value.default type, and here we can define our default type, and in our case we have the type com.bridge.message. If we again run this application and run the producer, so this time we are able to read this message. Here we have a couple of more properties with the consumer, like the auto offset. So it could be latest or it could be earliest. Like if you want to read the message from the beginning, we can have the earliest. Then it should be able to read all the messages from the last offset which it has read. As of now, we have the consumer group as group 2. Group 2 has updated the offset already. Even if we change this to earliest, it will read messages from the last offset and it has already read. But if we change the group to group 3, okay, and here if we run this application, let's see what happens. Alright, it is failing to read the values. We have the messages here which are string type and different values. So it will read all the messages which are of the message type. So here we have read the messages that are there. While reading these messages, consumer is sending the acknowledgement that this offset has been read. So next time it will only read the messages after the offset. Here we have one property, Spring Kafka consumer enable auto commit, and it is true. So every time whenever we read the message, it will publish that information to the Kafka and the latest offset will be recorded. Next message will be read only after that particular offset. If we make this property as false, still we have another property which is Spring Kafka Listener ack mode. So there are multiple acknowledgement mode. If we make it to manual, then our offset will not be recorded. For that we need to manually set it, and here in the consumer service with the consumer message we can also pass one more property which is the acknowledgement. After reading this message we can set the acknowledgement as acknowledged. Whenever we will receive the message, we will read it, we will do all the operation, and then we can set the offset by acknowledging it, and our application will be able to send this offset to the Kafka. Let's look at the last scenario here. At this time, our Kafka topic was failing to read the messages which were there, like these messages. It was only reading the message of specific type. But it is possible that one topic is receiving multiple types of messages. So how can we handle that scenario? In the producer application, we have another message, and here we want to send this message to the Kafka topic, and at the consuming side, we also want to read that message. So we have two different types of messages. Now in the producer application, one change we have done, and also we have one more thing that we can do over here. Earlier we were reading this listenable future. Now in the latest version of Kafka, you will see the completable future is the return type of the send message, and that gives us more abstraction on the future. So here also we can do one more thing. With the template.send we can return the completable future, and that is what we can do by calling the completable. And now instead of this return type we have the completable future type. We can write the response for the completable and when complete, and there we have two scenarios. So it takes the by consumer success and the throwable. So what we can do is, if we have objects is null ex, this is our success scenario, and otherwise we can just handle the failure scenario. We need to send this message here. Instead of producer service, we have another producer service. This Kafka consumer will receive the message, but here you can see the message is null. That means it has tried to convert this message to the message type instead of another message type. Kafka container does not know how to convert it, and we have disabled the header. And here you can see we have received the message, another message, and here we have the header com.bridge.dtos.another message. From the producer side we have sent this another message, but in the consumer side it is still trying to convert it to the message. This is happening because we have consumer that we have defined, and we have the default type as com.bridge.message. Now we need to handle multiple messages in the same topic. For that, the first change that we can do is, here we can just duplicate this thing, and this is going to take another message. This Kafka listener we can just use at the top level of the class, and here instead of listener we will use the handler. Okay, so here we have the Kafka handler. We don't need to provide anything over here. Same thing we can use with this method as well. Now we have two handlers. The first one is for the message, second one is for the another message. But the problem still we have is the type. So we have defined here the default type. It will only convert to one type. How can we map the multiple type? For that we have to do one change in the producer side and another change in the consumer side. Kafka producer is sending the header in the message, and the header belongs to specific type, and this type is not there in the consuming application. So here what we can do is, instead of having the header in the form of the package name and the class name, we can simply send some key, and that key we will map in our consuming application with some type. We have the application properties, and here we have the producer properties, and we want to map the types, and here we can define multiple mapping. So the first mapping that we have is com.biz.dto message. So we want to map this with message, and similarly another message for com.bridge.dtos.another message. With this property, if we will run our producer application, So here we have received the another message, and this time key that we have is another message instead of the class. In the consuming side, we have to make one more change similar to this. So here we have the consumer property mapping, and the same mapping we have done here. For the message key, we have the com.bridge.message, and another message is in the DTOH package. So here we have com.bridge.tto message. We have to disable this headers property. Let's run the consumer application. So here you can see we have received another message and we have got the value hello. Here we will enable this as well. Now both the bean will run and we will send two messages from here, hello 1 key 2. Let's run this producer. Here we have got two messages now. The message id1 hello, and we have another message id2 and hi all. This is how you can handle different type of Java objects as well. This is all about this consumer and producer side of the Spring Boot application. If you enjoyed watching this video, please like, subscribe and share, and also press the notification bell icon to get the latest update on my new videos. Till then, happy coding.